Okay, we were working in Lagrange multiplier section, and the problem we were looking at was trying to maximize the value of 3x plus 4y minus 3, subject to the constraint. So that's the value. So basically, this is what we have. We have a plane that's laying over top of the XY plane. And then there's a cylinder that's going up. And we want to know what's the maximum value this 3x plus 4y minus 3 attains on this inside this cylinder. Okay, so we found that the gradients have to be in the same direction. So we found fx and fy, gx, gy, we set them equal. And that gave us a relationship between x and y. So you will get one of two things. You will either be able to solve for lambda, which sometimes you can, or you will get a relationship between x and y, or x, y, and z. Okay, and then with that relationship, you can then solve for your points. So we have the values. X is equal to 1, x is equal to 4, or x is equal to -2. So we were solving and we found that so far. So now we need to go back and solve for our y values. Okay, so y, so if x is 1, I'm sorry, if x is 4, y is 4/3 times x minus 1, which is 4/3 times 3, which is 4. So that is the 0.44. And if x is equal to -2, so this is the 0.44. And if x is equal to -2, y is equal to 4/3. I'm going to get -2 minus 1 is -3. So I'm going to get the point -4. So that gives me the point -2, -4. Okay, so now if you remember when we were solving for this equation right here, I never wrote that. X is not equal to 1 and y cannot be 0. So x cannot be 1 in this relationship and y cannot be 0. Okay, so we have to check, we still have to check those points in the constraint. All right, so we must check x equals 1 and y equals 0 in the constraint. Okay, so if x is, so remember the constraint was x minus 1 squared plus y squared equal 25. So if x is equal to 1, we get y is equal to plus or minus 5. And if y is equal to 0, we get x is equal to -4 and 6. Okay, so that's where all my points come from now. Okay, so now I have the point 1, 5, 1, -5, and I have the point 0, -4, and I have the point 0.06. Okay, those come from the fact that when we were solving for the Lagrange multiplier lambda, those values were, we excluded those values, so we need to still check those values in the constraint. Okay, so now our function f of xy, if I can get this thing to come down, was 3x plus 4y minus 3. So f of xy was 3x plus 4y minus 3. If, of course, I don't remember, was it a plus or a minus? Yes. Okay, so the first point that we have is 4, 4. So f of 4, 4 is 3 times 4 is 12, plus 4 times 4 is 16 minus 3. So that's 28 minus 3, so that's 25. F of -2, -4. So that's 3 times -2 is -6, minus 4 times, that's 16, so that's -22, minus 3, so that's -25. Then we have f of 1, 5. So that's 3 plus 20 minus 3. So that's 20. And then f of 1, -5. So that's 3 minus 20 minus 3. So that's -20. I wrote minus 30, but I didn't mean to. Then we have f of 0, -4. Is equal to 4 times -4, which is -16, minus 3 is -19. And then we have f of 0, 6, which is 24 minus 3, which is 21. So we can now see that this okay, so this is our absolute max and our absolute min. Okay, that's how you do a function of two variables. I now want to go back and do this other problem here. So we are going to do this problem. So now this was that hard problem that I was telling you was a little crazy. You remember this problem?
The ellipsoid? I don't think you showed me yet.
I remember we started doing it over here.
Oh yeah, and you stopped.
Okay. Because I said, I know a better way to solve this. So let's see. So we want to find the volume of the largest rectangular parallelepiped. So we said that the volume of the parallelepiped that we're trying to maximize, we want to maximize volume, and the volume of the parallelepiped was XYZ because it was only, it was bounded by the coordinate axis, so it's only in the first octant. And it was subject to (36x squared plus 9y squared plus 4z squared is equal to 36. Okay, so now my f of XYZ is XYZ. And if you remember, what we did in the previous problem was over here for the G of XYZ, we solved for Z and put it in. So I'm going to do something a little bit different. I'm going to find the gradient of F and make it equal to the lambda times the gradient of G. All right, so F sub X is equal to YZ. F sub Y is XZ. And F sub Z is XY. Okay, so we got that far. So now G sub X is 72x squared. No, it's not. It's 72x. G sub Y is 18y. And G sub Z is 8z. Okay. So this gives me that YZ has to equal lambda times 72x. And this gives me that XZ has to equal lambda times 18y. And this gives me that XY is equal to lambda times 8z. Now, whenever you have a problem like this, it is always best to make everything look the same. So now watch this. I get XY, so let's multiply the first equation by X. So I get XYZ is equal to 72x squared times lambda. And then if I multiply by Y, I get XYZ is equal to 18 times Y squared times lambda. And if I multiply by Z, I get XYZ is equal to 8z squared lambda. Okay, so that means all three of them must be equal. So 72x squared lambda is the same as 18y squared lambda is the same as 8z squared lambda. So I can get rid of all the lambdas and get 72x squared is equal to 18y squared is equal to 8z squared. Now, it doesn't matter which one I want to solve for, but I'm going to pick one and solve for the other two. Okay, so let's suppose I start with 72x squared is equal to 18y squared. That says that y squared is equal to 72 over 18x squared. And I know that 72x squared is equal to 8z squared. That says that z squared is equal to 9x squared. $72 is indeed divisible by 8. I'm almost 100% sure. 9. What? Because 72 divided by 18. 72 divided by 18 is 4. So this is 4x squared. Okay, so now I go to my constraint. So my constraint says 36x squared plus 9 times y squared. Y squared is 34x squared plus 4z squared. Z squared is 9x squared is equal to 36. So I have 36 plus another 36 plus another 36 x squared is equal to 36. So I get 3 times 36 x squared So therefore, I get x squared is 1/3. So x is equal to positive or negative 1/√3. Good. Yay, we got an x. It took us a little bit of algebra, but it's not as nasty. Okay, so if that is x, what is y? Well, y squared is 4 times x squared. So that says y is positive or negative 2/√3. And z squared is equal to 9 times x squared. So z is positive or negative √3. Okay. So my function f of x, y, z which is x times y times z. Obviously, I'm not going to choose the negative values. I'm going to get 1 over the square root of 3 times 2 over the square root of 3 times the square root of 3. So I get 2 over the square root of 3 is the maximum volume. Okay. I'm going to do another one. Find the maximum volume of a rectangular solid given that the sum of lengths of the edges is equal to 4a. Okay, so I have a rectangular solid and I'm trying to maximize the volume. So what function am, so if I drew a rectangular solid, so I'll draw a rectangular solid. Okay, so here's my rectangular solid. And I need to find the maximum volume. So what are you going to make the volume? What's the function? You're going to maximize volume. What's your function going to be, Anaya?
Isn't it XYZ?
Okay, good. Now, what's your constraint? The lengths of all the edges is equal to 4a. All right, so here's one edge, X, here's another edge, Y, here's another edge, Z. So how many edges do you have? Anaya,
Yes.
how many X edges do you have?
Oh, 4.
Good. How many Y edges do you have?
4.
And how many Z edges do you have?
4.
And that has to equal 4a. Okay, so therefore we're good because this is G of X, Y, Z equals 4. Okay. Okay. So again, F sub X is YZ, F sub Y is XZ, and F sub Z is XY. G sub X is 4, G sub Y is 4, and G sub Z is 4. So I get X, Y, Z, X, I'm sorry. I get YZ is 4 lambda. I get xz is 4 lambda, and I get xy is 4 lambda. So now I'm gonna do the same trick I just did in the other one. Okay. Actually, I don't even have to do all that. They all equal 4 lambda, right? So if they all equal 4 lambda, they're all equal. So I get yz is equal to xz is equal to xy. So now yz equals xy, yz equal to xz says x equals y, and xz equal to xy says y is equal to z. So that tells me that x is equal to y is equal to z. So now I have my constraint. I have 4x plus y plus z is 4a. So that says x plus y, which is x, plus z, which is x, all equal a. So x is equal to a over 3. I'm sorry. This was supposed to equal, I wrote the problem wrong. I wrote the answer. This was supposed to be 12a. I wrote the answer. This was supposed to be, sorry, I wrote the answer. This was supposed to be 12a. And then this is supposed to be 12a. So now I get 3a. So 3a is equal to 3x. So x is equal to a. But that also means y is equal to a. And it also means z is equal to a. So that implies my volume, which is f of x, y, z. What are you getting, Bump? I want some. Is equal to x, y, z. That is a cubed. Okay. All right, so now the only other thing is what to do if you have 2 constraints. I'm good, thank you. Okay. I thought I had one with 2 constraints. Okay, here we go. Okay, so we have Lagrange multipliers with 2 constraints. All right. So f of x, y, z. All right, has a maximum or minimum value at the point x naught, y naught, z naught, such that I have two constraints now, g of x, y, z, it minus c is equal to a constant, or it's equal to 0, and h of x, y, z then there exist two constants. This time I'm gonna have a lambda and I have a mu. Such that the gradient of f at x naught, y naught, z naught is equal to lambda times the gradient of g at x naught, y naught, z naught plus mu times the gradient of h at x naught, y naught, and z naught. All right, so now this can be pretty ugly or not. Okay, so here's an example. Find relative extrema of the function f of x, y, z equal to xz plus yz if the point x, y, z lies on the intersection of the surfaces x squared plus z squared is equal to 2 and yz is equal to 2. Okay. All right, so I need to find the relative extrema, which means maximize and minimize the function f of x, y, z, which is equal to xz plus yz, if the point x, y, z lies on the intersection. So that means it's on two curves. It's on the first surface, x squared plus y squared is equal to 2, and it is on the second surface, which is yz is equal to 2. Okay, so now we need 3 gradients. Okay, so you ready to give me these 3 gradients? We need fx, we need fy, we need fz, we need gx, we need gy, and we need gz, and we need hx, we need hy, and we need hz. Can you fill all of those in for me right now?
Is that a 2
Where?
for the f of x? Which one?
F of x is xz plus yz. This is f of x.
Uh-huh. So for f of x, is that just finding the derivative?
Yes, we got to find the partials. So f of x, y, z,
With respect to x?
f of x, y, z is xz plus yz. G of x, y, z is x squared plus z squared minus 2. And h of x, y, z is yz minus 2. So what's f sub x?
So for that's with respect to x for the first one though, right? That's
Yep.
what I was asking.
Mm-hmm.
Yeah, that's what I was asking. Yeah, I thought you,
Okay.
yeah.
Yep, you're right.
So z plus y, oh, z. It's just z
Okay.
for the x. Do you want me to go across the board or go down?
Go down.
Okay. Y. I mean z. Sorry. X plus y. Two x. We're starting. You're on G, right?
Yep.
That's it. It's 0.
Mm-hmm.
2z. 0.
Mm-hmm.
Z
Mm-hmm.
and y.
Okay. All right. So now we're going to get z is equal to 2x times lambda. That's all we get. Then we get z is equal to 2z times mu. I'm sorry, just z times mu. No 2. And then the last one is x plus y is equal to 2z. That has to multiply by lambda, and y has to multiply by mu. Okay. So far, so good. Okay. Well, it's clear to see from the middle equation right away that mu has to be 1. Okay, so now that I know mu is 1, I get z is 2x times lambda. And down here, I get x plus y. This gives me x plus y is equal to 2z times lambda plus y. So I can see that the y's are going to drop out. And I get x is equal to 2z times lambda. So that's my other equation. Okay. If I multiply the first equation by x, I get z squared is equal to 2x squared times lambda. No, I'm sorry. I want to multiply by x. So I get xy, xz. And if I multiply the second equation by z, I get xz is equal to 2z squared times lambda. So these two equations have to be equal. So I get 2x squared has to equal 2y squared. I'm sorry, 2z squared. So x squared is equal to z squared. So now I have that much information. So if x squared is equal to z squared, I can take that and put it back into, so this tells me x is equal to plus or minus z. Okay. So now from this first equation, I have lambda is equal to z over 2x. And from the second equation, I have lambda is equal to x over 2z. That still gives me the same thing. Oh, I know what I'm doing wrong. Okay. So x squared equals z squared. Go back to the first equation. Where was that first equation? X squared plus z squared is equal to 2. Okay. So now the constraint g of x, y, z is x squared plus y squared plus z squared two. So now I have x squared plus z squared is x squared is equal to 2. So 2x squared is equal to 2. So x is equal to plus or minus 1, which means z is also equal to plus or minus 1. And now I have to go back and solve for y. And so my other constraint is yz equals 2. So if z is equal to 1, then y is equal to 2. And if z is equal to -1, then y is equal to -2. Okay, so now I have a bunch of options. Okay. So these are my choices. X can be 1. Okay, X can be 1, Z can be 1, and Y can be 2. X can be 1, and Z can be -1. And Y can be -2. okay? X can be -1, Z can be 1, and Y can be 2. Or X can be 1 and Z can be -1, and nope, X can be -1. Z can be -1 and Y would be -2. Now, what was my function F? F was XZ plus YZ. So F of 1, 1, 2 is 2 plus XZ is 2 and YZ is 2. How did I get 4? My function is XZ plus YZ, right? My notes are wrong. F of XZ is 1 times 2 plus YZ is 1 times 2. That's 4. My notes are wrong. Okay. F of 1, -1, -2. So XZ would be -2 plus YZ would be +2, and that's going to give me 0. Okay, this has got to be a different problem. I don't know where I got these numbers from. XZ is -2. Oh, XZ, I'm wrong. Nope. Oh, I got them in the wrong order, child. Got them in the wrong order. That's why I'm confused. Okay, let's go back. And you have yet said nothing. Okay.
Sorry, sometimes I catch stuff, sometimes I miss it.
Ooh, girl, we missed this one. Okay, X can be 1 and Z can be 1, and Y would be 2. X can be 1 and Z can be -1, and Y is -2. X can be -1 and Z can be 1, and Y is 2. And X can be -1 and Z can be -1, and Y is -2. Okay, now let's try it again. F of 1, 2, 1. XZ is 1, YZ is 2. That's how I got 3. I'm trying to figure out how my answer was so wrong. Okay, XZ is 1, YZ is -2, -1. F of 1, 2, 1, oh, -1. XZ is -1, YZ is 2, that equals 1. And then F of -1, -2, -1 is F of XZ is 1 plus YZ is 2, that equals 3. I still got one wrong. -1, 2, 1. -1, 2, 1. -1, 2, 1. Minus 1, 2. I don't think that is 1. If y is -1, -1, 1, 2. Now, why is this other one wrong? 1, -2, -1. 1, -2. I don't have a 1, -2, 1. That's the problem. I can't. Yes, I can. 1, -2, -1. Okay, so somehow before I got 1, -2, -1, 1, -2, -1 to give me 1. 1, -2, -1. So I have x and z is x and z should be -1. And then x and z should be -1. Plus y and z should be 2. And that should give me 1. Okay. Because I wasn't, okay, now I get it. Oh no, this is the absolute. That's the min. It's max. Okay. Woo. That was like crazy. Okay. We are now to the last. Let me check the schedule. Let me check my schedule. Pause.